Well, welcome back, YouTube. It's another old-fashioned winter day here in Northeast Ohio. It's been cold and snowy here for the last couple of weeks, and I, for one, am loving it. Aside from what the salt does to our vehicles up here, I really enjoy this time of year. I love the snow, and I don't mind the cold weather. I wanted to take a minute today and make a video that was recommended to me by a subscriber by the name of Shark Face Rides. He is working on his truck here, and he asked for some more detail about the axles and the axle codes on the OBS Ford pickups. So I thought, hey, I've got two great examples sitting right here. Let's talk about them a little bit. So this information will be specific to the OBS series of trucks, which is the 87 through 97 F250 and F350. The half-ton stuff I don't work with as much. I'm not quite as familiar with, but I believe this should be pertinent through model year 96. Again, the old body style of the half-ton pickups as well. But a lot of this information will be specific to the 3/4 and 1-ton F250, F350 trucks, just because that's what I've got here. That's what I've worked on the most. That's what I have the most experience with. So first of all, I want to take a minute and just talk about four-wheel drive, and we'll go over a few of the differences. Essentially, in these 3/4 and 1-ton pickups, there were two different front axles used. There's a Dana 50 TTB, which stands for Twin Traction Beam, and there's a Dana 60 solid front axle. So if you're not sure which you have, the F250 pickups all got the Dana 50 TTB from the factory. So if you've got a 3/4 ton pickup, unless someone has done a solid axle swap, the Dana 50 TTB is what you'll have. And it's easily identifiable by the presence of this pivot in the center. It's actually a two-piece axle. It has a regular carrier that's on one beam, but it pivots individually. It's a twin traction beam design. It's not a true solid axle. Now, people will say what they will about these axles. I don't think they ride terrible. There are some difficulties that go with having that extra pivot in the center. Keeping the pivot bushings in good repair can be a challenge. Aligning them is a little bit more difficult, but they're not a terrible axle. They're a pretty decent mid-duty axle. They are not, however, as bulletproof as a solid axle Dana 60. This one happens to be a dually, which means that it has the dually hubs on the end here. The hubs are deeper, but this is a solid front axle Dana 60 1-ton axle. So you can see steering geometry is different. It's a solid axle. Both are leaf sprung. They do use different leaf springs. The Dana 50 has thicker springs, just because of the way that it bears the load and the way that it has that pivot in the center. The springs are stiffer. So if you do a solid axle swap on one of these trucks, make sure you get your Dana 60 springs and put them under there as well. If you don't, and you use the Dana 50 springs, it's going to ride like a hay wagon. It's going to be very, very stiff. So that's kind of the two axles that were used in the 3/4 and 1-ton. As I said, the half-ton stuff I'm not as familiar with. I know that they used, I think it's a Dana 44 in the F150, And then they used a Dana 35 and a 44 both in the Rangers during this era as well. I've done some work on the Rangers of this era because my dad had one. Another note on these is that there are two different varieties of the locking hubs. The Dana 60s, every Dana 60 I've ever seen had manual hubs. So that means if you need four-wheel drive, you've got to get out and turn this hub from free to lock. And what that does is it basically ties the hub here to the axle shaft going through the axle. So with this in free and the transfer case in two-wheel drive, the axle shafts are not spinning. The universal joints are not getting any wear on them. You're not spinning the front differential at all. As soon as you lock this in, it ties this wheel through the hub to the front axle, and you're spinning the assembly in the front. So some people don't like that. If I get stuck in the mud and I don't have my hubs locked in, I have to get out in the mud, turn those knobs on both sides, and lock in the hubs. I don't mind them. I tend to just kind of lock them in ahead of time if I think I'm going to get into something that's potentially messy, and then I'll get out and unlock them before I get on the road. Or in conditions like this, if I think the roads may be slippery, I'll just leave them locked in. Now that does spin everything in the front end. It's a little harder on fuel. It does put a little more wear and tear on the components, but it's not a bad option. Now the other option on these was that there are auto locking hubs available on some of these trucks. I suspect that this truck had auto locking hubs in it, and they were replaced with this set of worn hubs. The auto locking hubs that were used in the OBS trucks are not, contrary to common belief, vacuum operated. They started doing vacuum hubs when they went to the Super Duty series of trucks in '98. These are not vacuum operated. These are actually a mechanical hub. Now the downfall of that is that the way that those hubs worked, you needed to be able to move the truck a little bit once you pulled the transfer case into gear in order to activate those hubs. So if you were already stuck and you weren't able to move the truck, especially as those hubs got worn or as they got a little bit dirty inside and they started to stick, sometimes it was tough to get those to lock in. So some guys don't like the auto hubs. If they didn't, a lot of guys replaced them with an aftermarket worn or mile marker hub or something along those lines. Now, one of the reasons that I like these manual hubs, and it's especially the case on a 5-speed truck like this, is that if I'm towing or I'm maneuvering around a driveway or someplace with a lot of obstructions in the way, with those hubs unlocked, I can put the transfer case into 4 low and I have 2 low. Again, the hubs are unlocked, the front wheels are not locked in, so it doesn't slow me down in my turning radius. You know, I'm not crunching and gritting and binding those front wheels around, but I've got the low gearing of my low range through the transfer case. I use that a lot when I'm backing my camper around. I'll leave the hubs unlocked, I'll put the transfer case in low range, put it in reverse, and I've got 4 low, or 2 low rather. So especially with a 5-speed, that's nice if you're pushing a big load around. With an automatic, it's not quite as crucial because you've got all of the gear reduction that happens in the transmission. You've got the fluid coupling of the torque converter. It's just a little bit easier to move around at low speeds with an automatic. So that is one reason that I actually like the manual hubs on these trucks. I can leave them unlocked and use 2 low. So 2 different options. I believe that the automatic hubs were kind of standard equipment on the F250. Somebody, I'm sure, will correct me on that if I'm wrong. I've never seen an F350 with auto hubs. I've seen an awful lot of F250s that had those auto hubs. So I think that was more commonly used on the F-250. It wasn't quite as heavy duty a truck, wasn't built for quite as much abuse, or just outfitted for as much abuse. So I think they probably got those automatic hubs a little more commonly. So 2 different front axles, 2 different arrangements of lockout hubs. Again, I don't think either one of them is necessarily bad, but probably the heavy dutiest, the most foolproof, most bulletproof setup would be solid front axle, Dana 60 with the manual hubs. That's my opinion, but that's kind of what I've come to through experience. Now, as far as the rear ends go, with the exception of dual rear wheel and single rear wheel, all of the rear ends in these F-250s and F-350s are the same. All of the OBS trucks got a Sterling 10.25 or 10 1/4 rear end. And 10 1/4 is the outer diameter of the ring gear on those. That's kind of how they rated these axles. Now, on the OBS trucks, again, which would be 87 through 97 for the 3/4 and 1 ton, there were mainly 2 rear end ratios available: 3.55 to 1 and 4.10 to 1. 355s and 410s. 355s were a little bit more like a highway gear. I actually have 355s in my F350 crew cab that's down in the shed. I do a lot of towing with that truck. It has a little more than stock horsepower, but the 355s are a great highway gear. In that truck, at 2200 RPMs, I'm going about 72 miles per hour. This truck, and actually Toothless here, both have 410s. At 2200 RPMs in overdrive, I'm going about 65 miles per hour. So engine spins just a little bit faster to go the same speed if you've got 410s. However, they are better for towing. They give you a little more low-end grunt and acceleration off the line, and they tend to do a little bit better in the hills. So there are a couple of ways, actually there are 3 or 4 ways, to identify which rear end ratio you have. So I will go through those here one at a time. The first way, and it's probably the most foolproof, but it's also a little involved, the most involved, I would say, is to just count the rotations. So if you were to jack up the back end of your truck, what you would want to do is put the transmission in neutral with the wheels off the ground and spin the input to the rear end. Spin the pinion. And what you're going to do is count the number of revolutions of the pinion that it takes to make one full revolution of the tire. A 410 axle will take just a little bit over 4 full rotations of the pinion on the input to make one full rotation of the output. 355 gears will take about 3.5 rotations of that input to produce one full revolution of the output. So that's probably the most foolproof way to identify this, is to actually verify. Now, the other thing that you can do if you happen to be into your rear differential for purposes of changing fluid or servicing things is count the teeth on the ring gear and divide that number by the number of teeth on the pinion. So a 410 axle will have 41 gears, say, on the ring gear, and 10 teeth on the pinion. So you divide 41 by 10 and you get 4.1. That's a 410 axle. A 355 gear, I believe, is something like 35 teeth on the ring gear and 10 on the pinion or something to that effect. But doing the math there will also get you to the same destination. It'll tell you what that rear axle ratio is. And when they rate axle ratios, that's exactly what they're doing. They're just rating the number of revolutions of the input to 1 full revolution of the output. And you can get that either way, either by counting the revolutions or by doing the math based on the number of teeth on the gears. A couple other ways that you can do it. This rear axle actually still has the axle tag on it. If you've got this axle tag, you may be able to read what axle ratio you have. This one is a little bit difficult to read right now, but starting on the upper left-hand corner here, sometimes the first number is under that bolt head, but this one says 4.1 LS. So that is a 410 limited slip carrier. So I know that unless somebody has changed something, this truck has a 410 rear end, and it is a limited slip carrier. Now, if it doesn't say LS, you have an open carrier. GM guys would call that posi or not posi. You know, an open or posi traction rear end. That was GM's trade name for their limited slip. Ford just calls it an LS rear end. It's limited slip. Now, a lot of the limited slips in these trucks have kind of been worn out. You know, most of these trucks have a couple 100,000 miles on them now. The clutches in those rear ends have worn out, and the limited slip may or may not work like it should, but they can be rebuilt. And at some point in the future, maybe we'll make a video on doing that, rebuilding the clutches that go into that carrier to restore some function to the limited slip. So if you've got an axle tag on there, that's a great way to identify it. If your differential has been serviced a lot, it's possible that that tag may have broken, or somebody may have just thrown it out when they took it off. I always try to clean them up and put them back on there when I'm working on them, but yours may or may not have that. The final way to try and determine what you've got in the rear end of your truck is through the use of the axle code on the VIN sticker. So I apologize for making you seasick here, but on this truck, down here at the bottom, you'll see a bunch of information. So first of all, we've got the wheelbase. This is a 133-inch wheelbase. We've got interior code 5R4. But the important thing is this axle code, axle C5. Now, I will list in the description below here a list of the axle codes for these trucks. And if you reference that on Ford Truck Enthusiasts or you Google it, you can use that code from the VIN sticker to at least find out what axle ratio was originally in your truck. That'll get you pointed in the right direction. So if you have a tag or you've done the calculation and you just want to confirm, that's probably not a bad place to look. Look at the axle code. Or if you're pretty sure that your truck hasn't been fooled with, that axle code a lot of times is correct. So again, two different axle ratios in these trucks, 355s and 410s. 355s are a little more highway rated, a little better for cruising the interstate. Not quite as good for towing, though I've done a lot of towing around 7, 8, 10,000 pounds with my truck, and it does a pretty good job. So that's kind of a rundown of the axles that are in these trucks. If you've got questions about those, if you've got, if you're not sure exactly what you've got, you can always do some of the calculations that are involved. I have heard that there may be a third axle ratio used in some of the heavy-duty trucks. Namely, it would be like the ambulance package or the F Super Duty truck, which would have been this generation's equivalent of an F450. I think some of those got like 456 gears in the rear end, which enables them to just absolutely pull down a house. But at anything above about 65 miles an hour, they're just screaming. They're just absolutely howling. Another thing that'll make a contribution to that is tire size. Guys don't take into account how big a difference it makes to change the tire size on these trucks. This dually has two 35/85s on it, which are a little bit taller, a little bit wider than the stock dually tires. The stock tires on a lot of these dualies were 215s, so they're little tiny narrow pizza cutters. And even with 410 gears, those things are really screaming, which is one of the reasons that they tow so well. You know, the turbos on these 7.3 Power Strokes don't really light until somewhere around 2,000, 2,200 RPMs. They really get into the heart of the power band. So at highway speeds, if you can get your RPMs up to that level, there's not a whole lot that's going to slow you down, even though they were initially rated at 215 horsepower. So getting the RPMs up there definitely helps as far as towing is concerned. Guys, that is what I know about the 3/4 and the 1-ton OBS pickups. I appreciate that recommendation for the video from Sharkface Rides. If you've got something that you'd like us to go over on these trucks, or if there's something that you'd like us to compare, or something you'd like us to try, I'm not going to tear the trucks up, but absolutely post a comment below. Let us know what you'd like to see. I'd love to make a video that helps people out. That's why we're doing this. So that is it for now. Thanks for watching. And I'll put a link in the corner up here to the rest of the videos on this truck. We're calling this one Project Frankenstroke. It started as about half of a rolling chassis, and at this point we've got it running and driving on its own. So we're making progress. Guys, thanks for watching. We'll catch you next time.